Hello, everyone. I want to thank you and welcome you for coming and joining us today for today's webinar. I know some of you are joining us from all areas of the world here, so whatever the time of day it is, again, thank you for taking time out to join us. As Heather said, my name is Jeff Bonkoski. I'm the Western Area Manager for Hazardous Control Technologies. A little of my background was I retired as from being a career firefighter. Small community just south of the city of Detroit, which is called Trenton, Michigan. While working as a firefighter, I trained to the level of a hazmat specialist. I was a paramedic and etc. So I, through my career, tried to learn as much about hazardous materials, high hazard fires, and things that made firefighting sometimes a difficult and dangerous profession. And my goal was to hopefully make firefighting a little bit safer. And so after retiring, I started doing consulting work with the ethanol industry, and when approached by many chiefs asking how I would deal with the fires. In most cases, my response was let it burn, for the simple fact you don't have the resources. One, enough foam. And we'll see, and I'll explain why as we go through the presentation. So with that, I felt that being the 21st century, there had to be a product that was on the market or available to firefighters that would be able to work on the fires and in uses where foams are not capable of being able to extinguish a fire. And through that search, I stumbled across Hazard Control Technologies and the F500 encapsulator agent, which we're going to be talking about as we go through this presentation. So we're going to be talking, and as it says here, working to encapsulate the world. The mission of HCT, much like myself, was to hopefully make, well, the firefighting profession safer, but on a more general, broad basis, the world a safer place. And we're trying to do that with our leadership in fire prevention, protection, and suppression systems, and using a fluorine-free product. We see in the news, and we hear and watch and understand that the current fluorinated foams are carcinogenic. They're environmentally unfriendly. They're called forever chemicals. Each and every time you're exposed to these chemicals, you bioaccumulate. So we're very proud, and we have been tested to be shown that we are fluorine free. We are based out of Fayetteville, Georgia. We have global distribution center. But one of the other things that I want to point out, especially when we start talking about lithium ion batteries and some of the other hazards, while these hazards are new, and we're going to show some very promising test reports that show the effectiveness of encapsulator agent on all these different types of fires. We've been around since 1997. So it's not a new product. It's just been coming to the forefront as a solution to dealing with these high hazard fires in a safe manner that's environmentally friendly. So as we go through, I want to cover these areas as far as fire suppression. We'll see some spill control, that vapor control, and I'm going to key in on that vapor control, especially for those in the fire service, dust control, and then we'll touch on some lithium ion batteries as we go through as well. I want to start with just a video, and it's for the title of the presentation, you might think, why am I showing materials in a structure fire? We're looking at these furnishings and these rooms, and it's a test that was done showing how back years ago when materials in the house were natural fibers, okay, the fires didn't grow as quickly. And the reason why I'm showing this is because where are these materials made? They're made in our industrial centers. Okay, they're packaged in synthetic materials. But we'll see how with the natural fibers, it looks like the fire is growing, rather faster, and that's on the left, than the synthetic on the right. But we'll see that once it starts to grow, it just kind of stays in that state. But let's look at the black smoke coming off the synthetic materials. Okay, that's what's killing our firefighters. That's what's making life safety in a structure fire shorter. People, the survival rate in today's structure fires, in today's industrial fires, in today's fires is greatly reduced because of that black smoke, the carcinogens, the toxins. Okay, they're killing us much quicker than, as you can see on the left, natural fibers. So that's why when firefighters get that call, it's a lot more important for them to get there in a timely manner because of the rapid growth of a fire. And it's the same thing when we look at fire growth in our structures or in our industrial settings. Excuse me. So when we sit there and we start looking at all of these different applications, yep, we're going to be getting into the industrial side, but it's an effect across the board and no matter where you're at. So hopefully when we go through this, we can look at how the encapsulator agents are giving us a better ability to deal with extinguishing these types of fires that we're noticing we're needing more and more water to extinguish because the fires are burning hotter. And as we understand, I mean, water is really, when it comes to doing firefighting, a poor conductor as far as being able to cool. We're using steam, and we're using maybe 3 to 5% of a water droplet to actually cool and extinguish. And I'm going to show you how an encapsulator agent improves that and helps us out in being able to extinguish these fires using less water. So the objectives are to hopefully help you understand, the risk of the hazards, what we're faced with, how an encapsulator agent is different than a foam and why we work differently. We're not a replacement for, but we are able to work on fires that foams cannot. And, talk about the applications that we're using it correctly. We're not wasting it, especially again, if you're a firefighter, and budgets are important. But the other thing I want to talk about, is when we talk about the industrial side, because how many times in the news do we see when an industrial fire occurs, again, that black smoke, the carcinogens, the toxins, the chemicals that are involved in that fire burning, okay, they're giving off those gases, and what's happening to the community? In many cases, we're causing an evacuation. So let's see how we can have an effect and maybe reducing some of that carcinogens and toxins and soot and put those fires out quicker and greatly reduce the impact it has on the community as well as to the industries. So we'll go through and cover in this, I hope, and answer questions and be able to show you how this is very effective at accomplishing just that. So water's been around in the fire service and the extinguishing agent for forever. If we wanted to put a fire out, that was the way it was done. And then as we started getting into, the gasolines and the oils and the petroleum products, and, some of the other materials, and now flammable or combustible metals, excuse me, where water is not really the agent of choice to use to extinguish these fires. With Class D metals, we know we hit it with water, we have those huge explosions and the issues that those present as well. And we know with petroleum floats on water. So if we use water, that petroleum goes onto the surface of the water, it floats away. So now we get into the solution which came around, and that was foam, the AFFF foam, the aqueous film forming foams. They were able to basically smother the fire, putting a blanket between the oxygen and the fuel source and being able to smother the fire. Some of the problems with that, though, when we started getting into some of our tank farms, some of our other applications where it was used, and we need to understand with these foams, if it's creating a blanket, it's basically working on static pool fires. Okay, if we start putting an incline to that where the fuel's moving, if we start putting a flange, or we start putting a valve, or we start having that flammable liquid move, it becomes a three-dimensional fire. And I'll get into how in the foam annex, foam is not suitable for three-dimensional fires. But we haven't had a solution for that up until now. And I hope to, in this presentation, give you that solution. We'll be talking about the encapsulator agent, how it works, what are they, how they're able to work, and being able to extinguish these fires that foams cannot put out. Again, it's 100% fluorine free. It's been tested. It's non-corrosive. It's biodegradable, so it's not going to be something that's going to stay in the environment like the PFOSs and the PFOAs. It is a multi-class CULS NFPA compliant fire protection and protection suppression agent, as well as a combustible and flammable vapor. I'm going to key on vapor and liquid spill mitigation agent. And the reason why I keyed in on vapor, again, I'm going to pick on all my firefighter friends that might be on this with us, is what do you currently have in our toolbox in the fire service that works on a flammable vapor? That's going to prevent a gas vapor from reaching an ignition source, flashing back, or causing an explosion. Up to now, there has been nothing. I mean, you can use water to hopefully dissipate, maybe push those vapors around, but you have had nothing that you could use to spray on a vapor, encapsulate it, and eliminate that flammable hazard as far as it being able to find an ignition source and flash back. So I'm going to show, excuse me. I'm going to show a real quick animation. It's going to describe basically how encapsulator agents work. It talks about these spherical micelles that you see here, and that's the basic building block of an encapsulator agent. It starts with our molecule. Our molecule has a polar head, loves water, wants everything to do to be in water. And it has a non-polar tail, which fears water. And it does everything it can to get away from and out of the water. So when you put the concentration into the water stream, either through an inductor, batch mixing, water-driven proportion, however you get this into the system, as soon as it gets in, all of those molecules instantly form these spherical micelles because those tails from the molecule want to get away from the water. So now as that water with all those spherical micelles comes out in droplets, okay, those cocoons, those spherical micelles closest to the surface, they break apart and those tails stick out. And they actually cause or form a skin on the surface of each and every water droplet. Yet inside of each and every water droplet, there are still millions and millions of spherical micelles. Now, when we look at the tails that are sticking up, okay, and by putting that skin on the surface of the water droplet, we change the mechanism of cooling. With plain water, it's steam conversion. When we look at the spherical micelle, we call it thermal conveyance. And there is no steam that's made when we're used to put out a fire. What happens is that skin we put on the surface, those tails act like a heat sink and they drive the heat inside of the water droplet. Those micelles, those millions of micelles inside the water droplet, they rapidly absorb the heat faster than the water. Okay, and they slowly release their heat that they absorb into the water that surrounds them. And through that process, there's no steam. So when this is used to extinguish a fire in a structure inside of a building, where normally you would have to be concerned about, interfering with the thermals and causing, steam to converge down on top of firefighters or on top of people, that hazard is gone. Okay, you can now go in and you can start to spray up towards the ceiling. You start to drop those temperatures inside of a structure, inside of a building where you might have fire, and knock those temperatures down and actually make things cooler as
Encapsulator Technology.
Yeah, sorry about that. So again, I'm going to talk about and give you that definition. I've talked about this spherical micelle. It's a water additive. When you talk about the encapsulator agent and that building block, basic building block of the spherical micelle is basically with the agent. It is capable of being able to encapsulate the polar and non-polar hydrocarbons, again, vapors as well as liquids. And instead of working on that mechanical basis by causing a separation between the fuel and the oxygen, we're working on a chemical molecular basis. Okay, so we're totally changing how we work on being able to extinguish these fires and the amount of water and, again, agent that's needed to be able to deal with these high hazard fires. When we go into and we look at where NFPA 18A section 7.7, that covers that spherical micelle stability test. It covers this agent. So, yep, encapsulator agents do have an NFPA standard that they meet. Again, NFPA 18A, that section 7.7, the spherical micelle stability test, it goes over what we just saw with that animation. It goes over how it's able to work on being able to extinguish and neutralize flammable liquids so that they're no longer flammable. And we'll see that here coming up in just a second. What I'd like to do to start with, though, is show a real quick introduction to the encapsulator agent. It kind of covers all of the categories that we'll be talking about as far as types of products. You'll see the classes of fires, pretty much all of them. Things I'm going to point out as you watch the videos, black smoke turning white quickly, and there's a reason for it. Here you have some tires, not very many, but again, with water, it would have been a little bit more difficult. A car fire, on this particular one, again, black smoke, we're rapidly turning white. You see as he comes into view, he's using a nozzle that only flows 20 gallons of water per minute, self-educting. We look at this pool fire. He's aggressively attacking it. That's not the way you are supposed to use foam. You look at alcohol. Again, same thing. Rapidly attacking the fire. You don't see a foam blanket, yet he's quickly able to. Now, the three-dimensional fires that I talked about, foam not being able to extinguishing. Here's a great example of an encapsulator agent. Not a lot of water, 95 gallons per minute, being able to extinguish it, mock-up of a jet engine cowling. How about natural gas or LP gas? The lithium-ion batteries that everybody talks about water when you use these batteries reignite. Here you can see he's just using short little, sporadic burst of encapsulator agent on without having reignition occur. Class D metal with water, you would watch, these types of metals explode, shooting sparks or molten metal up into the air. Again, think back to the animation. I put a skin on the surface of the water, so it's not truly water that's coming in contact. Here we have a transformer that's failed. It's now the oil in the transformer that's burning. Yet F500 in a matter of seconds was able to quickly extinguish that fire. So when we look at, case histories of previous instances where transformers or some of these, molten metals, the class D metals and things like that have burned, and firefighters get injured and killed because of the explosions that occur. Here again, we start to see some examples, just real short, but some examples where this can be used to safely mitigate these fires. And as again, we go through this presentation and I mentioned things, if there's anything that is talked about or mentioned that you would like more information on, please, when we get to the end in the comments or in the questions, feel free to ask, and we can sit there and get into some more detail, some of the things that you might want to get more interest or information on. So let's start looking at the applications. Applications of this agent, again, are versatile. And some of the other things that I want to talk about as we go through, because in reading comments and different blogs and a different post, I think there's a lot of misconception as to what an encapsulator agent is, because there are so many different companies that are starting now to use the term encapsulate, encapsulation, encapsulator. So by all means, I'm hoping to set ourselves apart and help you understand what F500 encapsulator agent is and how it's different than others that are talking about or using that term in their advertising or with their products. So as we go through, let's look at how this agent works and being able to encapsulate, how it's able to reduce the reignition by a couple of methods. One, being able to cool reignition sources, and two, being able to encapsulate fuels. And then we'll see and talk about that burn back resistance that I'm bringing up for the first time. Burn back resistance is a huge thing, especially when you sit there and you start looking at class 8 type fires or many other fires. Let's first start again with the heat reduction mechanism, because it's important to understand that when you use the encapsulator agent, we're not going to create that steam. But at the same time, we're also going to take temperatures that are in excess of 1200, 1300 degrees and drop them down below 120 degrees in a matter of seconds. So again, let's think about that animation. I shouldn't say the animation, but the video, the introductory video where we had that a mock-up of that jet engine cowling, that three-dimensional prop. Okay, what is one of the biggest hazards or reasons why we keep having reignitions? Okay, we might be able to put the fire out, but temporarily, because you have that hot steel that is still hotter than the auto ignition temperature of the fuels or whatever it might be around. So you're getting that reignition. You need to be able to cool the steel down below the auto ignition temperature so that you don't have it. Well, understanding that fire tetrahedron, if we remove any one of the three legs of the triangle, which is the heat, the fuel, or the oxygen, we understand you've extinguished the fire. Okay, well, here we are. We're taking temperatures in excess of 1,000 degrees and dropping them down below 120 degrees in seconds. We are removing that reignition source. We're removing the heat. Okay, and as we go through, we'll see how we encapsulate the fuel. So we're going to work on multiple legs, in fact, all legs of it. The interruption of the free radical, okay, where all of that toxic black smoke is. Okay, we're having an interference with the carbons and the hydrocarbons and improving the air quality. And in a Clemson report that we have, it shows just how drastic an amount of change that we cause in being able to reduce that soot and the carcinogens and the toxins. The eco-friendly, big thing today. People want to protect our environment. They want to protect, our basically ourselves, and why we're looking to eliminate the PFOS and the PFOAs. The problems are, is we're finding out that, that's what helps make foams currently so effective. And as we reduce it or we eliminate it, the foams aren't quite as effective as they used to be. But yet, let's get back to the encapsulator agent and see how effective it is in being able to deal with these fires, being able to rapidly extinguish them, and do it on an eco-friendly method. We use the old Swiss Army knife here because it's so versatile. There's so many things that this product is able to do in helping you get out of situations or conditions that current techniques might take us a while to do. So as I go through, we're going to talk about being able to deal with that hydrocarbon, being able to mitigate it, being able to clean the soil remediation. Again, flammable vapor mitigation. Okay, let's eliminate the vapors, not push them around with some water or some other method. Let's try to see if we can't eliminate the vapors as well as get rid of those fuels, making them non-flammable. I've talked about that rapid heat reduction, being able to absorb large quantities of heat, okay, without that creation of steam. And we're finding, that long-term stable burn back resistance, where once a wood or something is extinguished with the F500, it's not going to make it so that it will never burn again. It's going to make it so that it's going to require a lot more heat in order to be able to burn. So we'll talk about the ability to absorb that heat, the soot, the carcinogens, and again, through that process, we're going to improve visibility. So when we talk about the fire suppression, yeah, we're using some pictures here showing some some heavy black smoke, and we're again going to talk about how it's covered. When we look at it, from the Clemson report, it shows that we were able to reduce, the smoke and the toxicity of the smoke by 97%. So it improves that visibility, improves the IDLH environments. I'm going to mention again that fluorine-free, being able to reduce the the cancer-causing toxins by up to 98.6%, which is going to, again, structure fires or any fires. If we're not breathing it in, it's giving us a much better chance of survival. And if we're downwind in a community, it's even better. If we can knock those toxins, we can knock those soot down before they even make it. Because even when we talk about, doing those, we make the decisions to let things burn like we see in Ohio or elsewhere. What do we fear about? Where does all that soot, when it falls out of the sky, go to? Okay, now they're worried about the fields, they're worried about water, they're worried about so many things, as they should be, because it burns doesn't mean that all of the hazards 100% gone. So if we can come up and educate and show how we can be used to help reduce some of these toxic effects and deal with them on a much safer basis, it's what our accomplishment or our goal is. Again, encapsulating the world, making it a safer place, needing much less water. And the industrial benefits, that rapid cooling, the things that we've talked about up to this point, if they deal with Class D metals in their structures, okay, where you have to worry about hitting things with water, otherwise, you hit those huge explosions and fires because of the water coming in contact with your Class D metals. Okay, again, think back to the animation. I'm putting that skin on the surface of each and every water droplet. So it's not truly the metal that's coming, or the water that's coming in contact with those Class D metals. Okay, I put that skin on. I'm going to start reducing those temperatures, absorbing that heat without steam, okay, and being able to cool those metals down and extinguishing on them. So we go through and we can make these operations safer. We could sit there and in some instances, especially with fast moving fires, if you're an industrial facility and you've got a wildland fire approaching, being able to maybe treat the area around your facility can stop and prevent the fires from reaching you. Or any nearby structures. If it is a fire at your facility and you're trying to protect your exposures that are nearby, again, those are the types of things that we talk about when we talk about that burn back resistance. When we sit there and we look at the encapsulator agents, like so many other water additives in the fire service or that we use, it does reduce the surface tension of water. So it allows for the deeper penetration. It allows it to get into those small little crevices and nooks and crannies and things like that. As far as for bales and paper or coils, we can get into those areas that water droplets are maybe just a little bit too big and are slower to penetrate. So this has been a proven method of being able to extinguish. And I'm going to show this video. This comes to us because we often hear and read where, we have tire fires or recycling facilities. Again, the thick black smoke. This is in Gila River, Arizona, 1%.
Than 1 million tires go up in flames at a dump just a couple of miles north of Coolidge. You can see it right there on the map. That sent a cloud of smoke thousands of feet into the air. Sky Fox arrived on the scene minutes after it all started. This was the scene around 3:30. Less than 30 minutes later, the second row of tires catch fire, sending even more black smoke into the air. And this was the scene less than 3 hours later, after nearly all of the piles had caught fire.
Dust, rain, and high winds. High winds that carried the dangerous smoke close to the ground and into nearby homes. Tonight, there are evacuations, health concerns.
Good evening, everyone. It is officially a state of emergency on the Gila River Indian Reservation tonight.
Blaze has been to battle. It certainly has been a bear environmentally, but like us, firefighters are just watching some 16 piles of tires burn. Now, each pile is 175 feet long, 50 feet wide, and 60 feet tall.
Night toxic smoke is responsible now for a second night of evacuations in parts of the Gila River Indian community like Blackwater. Bulldozers have been working since last night to push the 12 piles of tires that haven't burned away from the 16 piles that are burning. If they've moved them far enough, this fire won't get any bigger. Hope number 2 is a second shipment of firefighting foam, originally scheduled to arrive from Georgia at midnight, now expected around 3 a.m.
Firefighters say a foam chemical retardant seems to be helping extinguish the fire, and they are trying to arrange for emergency shipments of more foam and water.
Now, that fire retardant was flown in from Atlanta, Georgia, and trucked up here from Sky Harbor Airport.
And it seemed to have turned the black smoke into white. Then you add more water to it, then it seeps down and puts out the fire.
Well, we're going to show you, Marty and Scott, because it's the third day of this fire, and they have done a lot of work on it. You can see from up here now there are some piles that are still putting out that black smoke. Some of those piles, though, have changed to putting on a white smoke. The reason for that, they're putting a fire retardant on those. You can see the trucks down there.
That's right. This has been a very difficult fire to fight, but
Okay, I'm going to stop it there. But point out, as you go through and you hear, it's F500, the encapsulator agents, again, being referred to as foam, retardants, and all the other things. It was the F500. The things that I wanted to bring up is a couple. One, that ability to turn the black smoke white, as it was stated by multiple people in this news clips. Other thing that I wanted to point out is, it was 2 days of using water and foam unsuccessfully. Being able to try to, one, contain or even stop the fire from growing. And you saw early on where it started from one of those piles of tires to then growing to include, so many more piles of tires. Yet once F500 was brought to the scene, on day 3, they pretty much had the fire out, in most cases under control, and they were just in the process of doing their overhaul. So it was a rapid change in being able to deal with this high hazard in a short order. Had it been used from the beginning, okay, chances are people downwind would not have had to been evacuated. You would have been able to extinguish this fire in a timely manner, and the community may have never known that there had been a fire at this facility. So it's all a matter of understanding the product and having it on hand and being able to utilize it as fast and as quickly as possible so that you can deal with these fires. Here's one with some ethanol. This is 100 gallons of ethanol, as I recall, and they're using a 3% solution. Again, 95 gallons per minute. They're not using, a master amount of water, or many cases, people are saying, oh, well, you need to have, minimally 125 or 185 gallons of water a minute. And here's 95 gallons of water a minute, using 100 gallons of ethanol in a pit. As you can see, fog pattern, broken stream, rapidly, aggressively fighting the fire with foam. There's 3 methods for using and applying foam. It's rain it down, bank it in, or roll it on. There isn't that special application when you're using the encapsulator agent. As you saw, aggressively fight the fire. And that's where, like say, we get departments that start to look at the product. We want to come and do some training. We want to make sure you're using it correctly. I'm going to play this one.
Highway 225 is shut down in both directions too. Good evening, I'm Jason Miles, in tonight for Ron Trevino. The chemical fire started about 12 hours ago and is only getting bigger. Stephanie.
And only getting bigger. Okay, so I throw this out there because as you saw at the beginning of the slide, it looked like there was one tank involved. As we go and we look at that bottom left, you can see how much it's grown. This fire burned on for days. And then it was reported that they finally had the fire out. And then, oh, no, the fire's going again. And then it was, oh, the fire's out. And this went on and on and on for like 3 days where the fire was out, the fire was going again. The reason? Because as the foam blanket broke down and exposed that hot metal on those tanks, okay, that fuel reignited again. So they had to start their reapplication. Now, I put up here at the top, you see that, it shows the fire was believed to have started at a manifold. So when we sit there and we look, okay, here is what's believed to have been the initial cause. It's a three-dimensional fire. And let's go back up here. That's what foam's going to do. Foam is not going to work on a three-dimensional fire. It's not going to put it out. So with encapsulator agent, we could have dealt with and we could have extinguished the fire right here at this manifold. It would have been the end of this fire. Yet we end up with a fire that impacts the community. It impacts the environment because at this particular scene, there is so much foam and water used to extinguish it that the dike around it had a breach. Much of this water and much of that fluorinated foam got into a waterways that surrounded this facility. So it did have a huge impact on the community and the environment, which is still going on as far as the cleanup. We look at, this clip showing encapsulator agent being used on three-dimensional fires. Example, this distillation column. And I know many times I've seen in the news, how facilities are being evacuated or areas are being evacuated because there's a distillation column fire. Here's a mock-up of a well, a blow-off. Again, one hand line, 95, or I think this was 125 gallons a minute. That jet engine cowling, 95 gallons a minute. You'll see the fire's out, the jet fuel is still flowing. The only difference is you watch him change his pattern on the nozzle. Okay, he tightens it up, opens it up. Okay, he's cooling that metal as well as working to encapsulate the vapors between the liquid and the fire. Once he gets it, he's done. That manifold that we just saw that caused that huge tank farm fire. Okay, looks like he's having some problems. Again, it's one hand line that's attacking this. He's working two things he's trying to accomplish, just like we saw at that jet engine cowling, that mock-up. He's trying to cool that metal, that's that ignition source, while he works to encapsulate the vapors and extinguish the fire. We're looking here where they're above ground storage tank fire, small one, cylindrical one, how quickly he's able to cool that tank and extinguish. Natural gas, LP gas, again, quickly able to extinguish, he cools. Now they can reach in there and we can sit there and we can shut off the valve while they continually to flow the F500 to continually encapsulate those vapors. Okay, you don't want to, just because the fire's out, shut things down. No, you want to keep flowing until you have that valve closed and you get that gas shut down. I know in my training when we would do it, we'd have two hand lines, crisscrossing each other and somebody be reaching through to try to shut that valve. Just how much different we can do things and possibly even on a little bit safer plane. So we look at spill control, how we deal with some of the spills where, again, foam is going to blanket it, suppress the vapors. It's still going to require that, you have a cleanup contractor come in. It's a temporary source. It's a source that you cannot walk through. If you walk through, you break the integrity of that foam blanket and you've reduced its effectiveness. And we'll see how, again, with the encapsulator agent, it's different. Your foams have what it calls runoff times, where you have to continually be reapplying it. In case in history that happened not long ago with an airport incident with jet fuel, because of the heat of the day, they were reapplying the foam every 6 to 7 minutes. because the blanket was breaking down that quickly. So then you have to sit there and you have to look at the size of the spill, estimate the size of the spill, do your math so you can figure out how much foam you need to flow in order to meet the NFPA requirements for the application rates. Look at the industrial benefits when you sit there and start looking at encapsulator agents. I mean, we could be used with salt water. So we've been used, and I've used it to mitigate a fuel spill on a ship, and being able to clean it up and to neutralize gas that was spilled down inside the bilge. What was thought to have possibly take millions of dollars and take years and clean up, we were able to accomplish in 3 days. Being able to mitigate, I think it was somewhere in the area of about 130 liters of 130,000, excuse me, 130,000 liters of gasoline in the bilge of a ship. So this is very versatile in being able to do multiple things and mitigating these spills where foams they're not able to deal with. Again, we threw out there the water supply, because if we're going to be flowing and we need you know, millions of gallons of water and foam to be able to deal with a fire, we have to come up with a water supply in order to be able to deal with all of these nozzles that we're going to be setting up, monitors that we're going to be setting up, and trying to fight these fires at these tank farms and some of these industrial facilities. And in many cases, a nearby water supply isn't readily available. So I kind of throw this one in there showing you just some of the issues and the problems. So now let's look at that ability to encapsulate and remove the hazards associated with a fuel source. Here we spread some gasoline on the ground. We've used the F500 to neutralize part of that spill that we've placed on the ground, and we light up the other side. We'll see that there is a milky white discoloration to the water. So we can see where the F500 has been applied. We're now going through and we're using the F500 encapsulator agent to extinguish the gasoline on the other side. And we're going to give it just a little bit of extra wash down. And here's where, again, we talk about that ability of it to encapsulate the fuel, making it safer and non-flammable, because unlike foam, he's going to stop here and he's going to sweep his foot, showing there's no blanket to break and there's no ignition. That gas spill is no longer a hazard. It's no longer a problem. It's been encapsulated. And you say, well, okay, now what's the cleanup? The cleanup is let it evaporate. F500 is on the EPA's National Contingency Plan as a surface washing agent. It has been approved. So this is no longer a hazard, and it can be safely cleaned up by letting Mother Nature evaporate it away. So there's a lot of advantages. Okay, again, when we look at that neutralization versus a blanket, okay, that blanket, you still need to have somebody come in and clean it up. Okay, environmental contractor. If you use sand, kitty litter, or whatever, you might have to send that off to a hazardous waste landfill where you're going to be responsible for it for as long as it's in that landfill. So think about it, let it evaporate away or financially responsible for it for life. Okay, so 1 gallon of F500 concentrate agent versus 36 gallons of an AFFF foam. That's what we're looking at when we're dealing with a 8-gallon fuel spill. And the reason why we say it's 36 gallons of AFFF foam is, hey, let's go to the NFPA the NFPA record, the standards, and say, hey, what is the amount that we need to flow on an 8-gallon spill to meet the requirements? Well, we only need 1 gallon, because if we look at the formula for being able to encapsulate 1 gallon of fuel, it's 1 gallon of gasoline. So the formula is 1-8-40. So it'd be 1 part of fuel, or 1 part F500, 8 parts fuel, 40 parts of water. So that's where we get the 8-gallon fuel spill from. 8 gallons, 1 gallon of of the F500, and then the rest is water. So when we get done and we look at the 40 gallons, versus, the 1,208 gallons of that foam solution that now needs to be, vacuumed up, it needs to be hauled away, it needs to be treated. Big difference. We look at, being able to make that scene safe in a matter of seconds versus, well, it says with the AFFF semi-safe in 15 minutes. And the reason why it's semi-safe, again, we can't walk through it. You have to worry about disturbing that blanket. And until it is remediated, you have a contractor come in and suck up the foam, suck up the gas, you still have the residual. So you now have to do something as far as, absorbing that residual that's still left on the ground. With the F500, again, we allow it to evaporate away, and it's not a hazard. And as listed on the very bottom, it is listed with the US EPA as a surface washing agent. So there's a lot of advantages for using the encapsulator agent for spill situations, because it's going to need much less than you are going to need with water. And if it's if it's, we're showing here 3%. Okay, if we're looking at, your AFFF, if it's a polar solvent, an alcohol, you're going to be using 6%. So you could be using much more foam than, again, you would be with F500, because maximum you'll ever use, be hydrocarbon or polar solvent, is that 3%. So when you sit there and start looking at those alcohol resistant foams that require a 6%, you're really then doubling your cost. So there's much less water, less staking that's going to be required. The potential runoff, you have to worry about because of EPA, especially if it starts getting into waterways. Your cost to clean up is greatly reduced, again, if it's going to be Mother Nature evaporating it versus having to have a environmental cleanup company come in and to do the cleanup after the fact. How about firefighter fatigue and stress, or how about the exposure to contaminants with our turnout gear? And when we start getting into the heat of the summer, when you start getting into temperatures are up in the 80s and 90s, high 90s with high humidity, what's the stress going to be in the heat going to do to our firefighters when they're on those scenes for hours and hours and hours waiting for a contractor to come and clean it up, where that heat could actually be evaporating and mitigating it while we watch. So day and night between the two and how they work. Let's talk about vapor control. And yep, I talk about this because, many times you'll sit there and you'll, again, watch on the news where there's a leak at a refinery, or there was a leak at a pipeline or a facility, which led to an explosion and fire. Let's hope that in many cases, no injuries, but unfortunately, many times there are injuries. If systems were in place, and we'll talk about this VEEP. The VEEP is the vapor encapsulation explosion protection, where monitoring takes place, LELs start to rise, the system can be activated, those vapors can be encapsulated, eliminated, and then we can sit there and we can, once those vapors are gone, because safety devices have been tripped or triggered, now instead of a plant having that explosion and fire that takes them offline for maybe months or years, while they end up having then to rebuild, it now can possibly be hours to days because of just the need for replacing some gaskets or replacing a section of pipe or something that can be quickly repaired and getting these facilities back up and running. So this technology can greatly protect facilities that have those types of incidents. When we look at that vapor and that vapor explosion and how it works, let's look at, this is back from 2007, but it talks about the fire department responded to an estimated average of 51,600 fires annually where flammable gas was identified as the source of ignition. So while, yeah, it's not going to be maybe useful in necessarily a residential structure, but when we start looking at industrial, or we start looking at some of the other areas where these vapor hazards could be a problem, okay, and we can get these monitoring systems put in place, and we can put these encapsulator protection systems in place, it make a huge difference. And just as an example, here is an area at a facility that deals with, flammable gases or flammable liquids. This is a safe area. Okay. But again, we often hear about how some of these gases don't necessarily have an odor to them. So what was thought to be a safe area for the employees to have as a smoking area wasn't so safe after all. Here we had some vapors that got away undetected, and unfortunately caused injury to some of the employees. I'm going to show this one. This is some testing that is trying to hopefully create some type of a safety around a LP tank, and they're looking at some water. And as you can see, it's a relatively large water curtain that they put around this tank. And even though they have all that water spraying beforehand, I'm going to back it up just for a little bit, because you're going to see around the bottom, you see that flare that was thrown in. Okay, so even though we have all of that water flowing, they've got gas turned on, and once an ignition source was found, it was still able to flash back, and it was able to catch that gas on fire, even though we had all of that water flowing and trying to mitigate or prevent it from happening. So once that happened, they then decided that let's now go to a second layer of protection. Let's open up a second ring around this particular test site, this test, to see if we add even more water, whether or not we can have an effect in being able to control. And you're going to see here the flare is going to come in from the bottom of the screen again. They've got the gas burning, and once they go ahead and get the flare thrown in, you'll see that it's going to catch it on fire. I will say, as far as the gas getting outside of the water vapor, because you do see the flames on the outside, it did offer some protection. But depending on the type of gas, LP has a tendency to lay low to the ground, where natural gas has a tendency to float a little and float up and be less of a hazard. So it depends on the nature of the beast, and I'm not sure exactly if that was natural gas. Hazard control technology. We're going to look at now what is called the Vapor Encapsulation Explosion Prevention System, or VEEP, and see how, when it comes to that flange, when it starts coming to some of this piping and things like that, using the F500 in a system that surrounds these, just how quickly it can have an effect on being able to extinguish these fires. So here you see, you've got, that fire going, and think back to that tank farm where I showed that manifold. Okay, if a system like this had been nearby or around that manifold, that fire was out. You see the milky white discoloration in the water, showing that the F500, again, we start looking at another example, but just how quickly, with the encapsulator agent in the water stream, it's able to have an effect of being able to extinguish these fires and being able to prevent them from happening. We now are going to move on and start talking about dust. dust is a huge hazard. And when we sit there and start looking and instances which happened, it's a hazard for the fire service because they don't get much training. Dust really isn't one of the things that are big in the fire service training manuals. Even when you start getting into the hazmat side of things, while they deal with the liquids and chemicals and things like that, there's really not a lot that's covered in dust. And that's why when you have dust instances or you have fires at facilities that do have problems with dust, that firefighters in many instances can get injured because of the simple fact that they truly do not know how to deal with these correctly. So we're going to see here how the encapsulator agent can give a benefit to these. And we're going to go and look at some reporting that was done, and it shows here the global data in 2018 that 89% of the risk-related deaths, explosions were in 2018, 3 dust-related incidents were recorded with losses of more than 15 million. So dust instances are a huge problem, and they can be rather expensive. I talked about, the firefighters' response and not understanding the true hazard. And here we have a dust collector at a facility that has a hot spot. The fire department responds, and they want to react and they want to do what they can to hopefully mitigate this fire and get the facility back working again. And as you can see, sometimes that's not the safest solution to use just plain water when we're dealing with those types of fires. It can actually make things much worse, not understanding the potential and risk.
Silos packed with over 2 million bushels of grain. 40 men, 10 of them federal inspectors, were working the second shift in and around the big elevator when it blew. 6 of the dead were found on top of the rubble. Others remained buried beneath it, some under these railroad cars. It's suspected the volatile grain dust was ignited in an underground conveyor unloading grain from the rail cars. Was there any warning that this would happen? Strong, it was heard 70 miles away. Windows in downtown Galveston, a mile away, were shattered. Fire from the explosion burned many of the survivors. According to the Occupational Safety and Health Administration, OSHA, it was the 4th grain explosion in the past 6 days, the worst one coming last Thursday in New Orleans. OSHA says the Galveston grain elevator hadn't been inspected in recent years.
So while we don't hear about them as much as we used to, I mean, there's still the potential. I mean, we still have many areas, in the ag industry and the power industry and so many other areas where there is the potential for these dust fires. So this is some testing that was done, again, with encapsulator agent versus water. And it's showing the, again, benefit of adding the encapsulator agent in water and how much difference it makes. Here we have on the left plain water, there's an ignition source. The minute that coal dust is hit with the water and it comes in contact with that flame source, you see that fireball erupt. When the encapsulator agent, that 1%, is in with the water stream and they start hitting that coal dust, there is no fireball that's created. It's able to prevent that from occurring. So it changes the characteristics on how we're able to deal with these combustible dust situations in industry, making things a lot safer. And we're more than willing to help out our industrial partners and clients and trying to help them mitigate any instances where they may have at their facilities that do involve combustible dust and helping them to safely bring those to a safe situation. The next thing we're going to touch on just briefly, we'll have, like I say, we do have our training on lithium ion batteries that, again, we could do for people as they want. But lithium ion batteries are even becoming place in industrial settings because we're getting them in our high-lows, lift trucks. They're starting to talk about vehicles, trucks. So who knows how long before a lithium powered vehicle is going to be pulling into your loading dock to either get loaded or to unload product that your facility may need. So, these lithium ion batteries are becoming part of our everyday life, our phones, our computers, tablets, whatever it might be. You could probably look around right now where you're at and probably see 5, 6 lithium ion batteries within close proximity. So they're part of our everyday life anymore. The problems with these are, we hear in the news all the time, is how they can, because of overheating, catch fire. How they go into thermal runaway. And the thing of it is we start to learn more and more about them. It's that overheating and things that we're learning that causes that overheating or that battery to fail is that abuse, the shock dropping, not using manufacturers recommended cables or chargers on your phones or on your devices, which, because it doesn't maybe have the thermal protections built into them, is causing batteries to overheat, which then leads to that thermal runaway. And when they do fail, you see in videos that heavy smoke that comes off of these batteries because they're releasing this HF gas, hydrofluoric gas. So it's now not only the burning potential, but now we have a hazardous gas that's being released when they burn. And if we start using plain water, we're going to grab a hold of that HF gas, and now we're going to turn it into HF acid, which is just as nasty, especially if it gets on your skin, because HF gas is going to start attacking calcium in your body. So when we sit there and start looking at all of the bad what lithium ion batteries bring, we have to be aware of it because, people again are going to have that tendency of trying to put the fire out. Best thing to do is call your fire department, and hopefully we get some F500 on it and we'll see how it works. The extinguishment of lithium ion batteries, we're going to see when we talk about the encapsulator agent being able to rapidly extinguish them with less water, needing much less time, and it's going to reduce the risk to the personnel. It's going to start to encapsulate that HF gas, reduce the risk to people as well as to the environment. The benefits are that it's not going to require copious amounts of water like we keep hearing. And all of the testing that's been done on lithium ion batteries with the F500, it's able to greatly reduce the amount of water needed. When we talk about that HF gas, okay, and tests shown that were done with TL Claustel in university in Germany on behalf of Johnson Controls and HCT Europe, we find that, when levels that were as high as 2,656 parts per million, when these batteries were just allowed to burn, and then they did the test again using the encapsulator agent F500, they dropped those levels down to 37.45 parts per million. A great reduction. And if we sit there and we go into the NIOSH and look at a 10-minute exposure, okay, it's 95 parts per million. Well, we're down to 37 parts per million. So, you have better than 10 minutes to be able to exit that building when you sit there and you start using F500 and trying to extinguish these batteries and trying to extinguish them. I'm going to show this video comes to us from the Kiwa Labs again, testing that was done with HCT Europe, Johnson Controls, testing powders, foams, and F500 encapsulator agent. We go to so many of the recommended agents that people have, they recommend powders, excuse me, or foam. But here we're seeing with the encapsulator agent, again, just short little blast with the encapsulator agent, very able to quickly cool and extinguish the battery. Powders are ineffective. They don't work. The foam in the middle, same. It's not working. And we know with water, it seems that, people are saying that, water is the solution. The only problem with water is how many times do we hear that when water is used, hours to days later, we can have reignition. When we sit there and get into the encapsulator agent, in all the testing that's been done, we have not had a documented case that we're aware of where there has been a reignition of a lithium-ion battery. So right from the Johnson Controls reporting, from the Kiwa lab testing that was done, powders, 3 tests, all poor. Their remarks are don't apply. You look at foam, moderate to poor. Recommendation in the remark is not recommended. F500 encapsulator agent was sufficient all the way across the board in all tests and can be recommended. So if we go into a Johnson Controls website and search for a extinguisher for lithium ion batteries, you'll find that you'll come to the F500. In some testing that was done, this is a battery that would be utilized in a vehicle. They're overheating it. And the reason why I'm showing this is many people are under the theory that, we have to get into each individual battery in order to be able to extinguish the fire. This was done in this test is actually in, I believe, a 20-foot Connex box. And what they've done is they have set up 2 sprinkler heads, one at each end. So it would be like a building that is basically got a fixed sprinkler system in it. So one of the reasons why you're going to see this fire burning so long is because those sprinkler heads that are in this are ready to go. It's charged up and it needs to get to a temperature inside of this Connex box where it's going to cause the sprinklers to activate. So the fire's growing. You're getting, as you can see from the jetting and the fire, we're getting a lot of thermal runaway, thermal propagation that's taking place. It's going from pretty much one cell to the next, then with the battery. And we'll see once that system activates just how quickly the fire is extinguished. And as you can see, it was activated. We had good burning. Minute it activated, within seconds, the fire was out. So you really even can't tell exactly when that was actuated. This will give you a better idea of just how quickly the extinguishment can occur. And what you're going to see here, because this has got some temperature sensors on it as well. Here we have the cell that goes into thermal runaway. We've got some thermal imaging that's taking place. We've got some temperatures that are being monitored to show just how quickly the encapsulator agent is activated, and we watch just how quickly those temperatures are dropped. Again, once the battery is out, we have not had any reignitions. When we go to the NFPA 18A standard, if you go into the annex material and go to annex 4.3, in there it lists a lot of the testing that has been done to support and back up all of the abilities of the encapsulator agent to be able to control and to extinguish lithium ion batteries and their gases. We also can go and look at the Dutch standard, which is NTA 8133 standard. It deals with listing a fire extinguisher to be used on lithium ion batteries. F500 has been tested on batteries and approved for use on batteries up to 600 watt hours. When it comes to, I believe that was a 9-liter extinguisher. So we start looking at, the uses. We hear the smartphones, laptops, and so on and so forth. These are all battery sizes which are smaller than that 600 watt hour battery that an extinguisher can safely extinguish. So we do have the ability in other parts of the world where they are testing for a solution to being able to extinguish lithium ion battery fires. We do have standards and there are applications and uses where we have extinguishers that have approvals for use on being able to extinguish them. We mentioned that lithium ion battery in the Connex box. Okay, we can start looking at these engineered solutions, inside of buildings where these are being charged. And I mentioned the VEEP system. Let's look at all the different things. Dust control, that dust collector that we saw. Sprinkler systems can be used to protect those in the event of fires detected. So all these different areas, we talked about the VEEP, the dust control, we talked about lithium ion batteries, we've talked about, your Class A materials, we talked about the 3-dimensional fires and so many other things that have been part of or are part of our industry. We can sit there and we can look at the ability in some of the solutions. One is, mobile equipment. We've got extinguishers from 2.5 gallons on up to 100-liter, what we call our quick attack mobile units. We have portable carts, our TKO nozzle, which is 75-liter. We've got piercing rods when it comes to coal piles or it comes to those silos, combustible dust type instances. When we're looking at a warehouse, aircraft hangar, industrial settings, that VEEP system, being able to get the agent to be able to deal with those fire suppression systems. This is probably the most economical way to do it because every year you're supposed to be testing, and rather than having to have a source to remove the water to create a solution, with the water driven proportioners, we can sit there and we can test them to make sure that they're working properly, much better and much safer and a lot less maintenance. When we're dealing with the F500 encapsulator agent, we have our diamond doser, water driven proportioner, and with the conventional green foams, we have our fire mix. And then there's the old way of doing it, the bladder tank systems, which we also have many of around the area, around the world, I should say. We talk about the abilities of the agent, and when we do, like with foam, we wouldn't expect a person or a department to understand how from a short webinar or maybe a little demonstration to be able to be very familiar with how to use the encapsulator agent. So we offer the ability to come and do trainings, work more closely with your team, do multiple things, help you develop plans and help do trainings and helping people to understand the uses, the percentages that are needed, help you with creating SOGs or guidelines for your first responders, especially again, if you're an industrial client and you're at a facility and a department is still using a fluorinated foam. If you have a fire at your facility, they're going to be coming in and they're going to be using and they're going to actually be contaminating your area with a fluorinated foam. Whose responsibility is that going to be as far as the cleanup? Especially when we can sit there and we can start showing how things can be done safer, how we can put them out quicker, using less water, using safer technology. Training, we have trainings where we come and do lithium ion battery hazard awareness. the power plant hazard awareness, coal handling and bulk storage. We're dealing with that combustible dust, and we're dealing with some of these hazards. We can even sit there and start getting into some of the hazards that we get into with oil and gas, and dealing and being able to offer solutions and do visits to facilities and sites and offer some suggestions or comments on what could be done to make those facilities safer. To come in, do training with your local first responders, so that if they're going to be coming to your facility, how and best that they could use the encapsulator agent to protect your facilities. Again, the whole point is making it safer for the firefighters, for the facilities, and for the community. So with that, we've basically covered the NFPA 18. We've talked about the ability to encapsulate that section 7, the spherical micelle stability test, the rapid reduction in heat, that reduction, and I should say the significant reduction in the toxins and the soot and the smoke. The difference is, when we look at foam that falls under the NFPA 11, where it works on a mechanical basis, causing that separation, it's very poor at eliminating heat. When we think about a blanket, what do we do at night when we're cold? We're pulling a blanket up. It's keeping the heat in. It's really not doing a lot to eliminate the heat. And it does absolutely nothing to reduce the toxins that we can be exposed to. Inerting gases, well, those are a lot of times in our data centers, community centers, but we're also seeing that in those battery energy storage systems with lithium ion. Again, very, very poor when it comes to reducing heat, and does nothing as far as the toxin. Water, again, mechanical, poor as far as heat reduction because it uses steam conversion to help extinguish fires. So as we know, steam is still 212 degrees and will burn you. Minimal as far as the toxin reductions. It's not going to do very much to reduce what we're being exposed to. So with that, I'd like to open things up. I'll take a moment and thank again you all for attending, taking time out of your day. I do hope that I was able to give you a better understanding of encapsulator agents, how they work, the different applications that they can be used for, how they can make things safer, not only for firefighters, but for employees or for the community. And by all means, if, after you go to our website, or if you do visit and see any more of the websites on our webinars that are on our website and our YouTube channel, feel free to contact us. The biggest thing about the encapsulator agent is how so many people misunderstand how we work. The confusion caused by others that use that same terminology of encapsulator, encapsulation in their product descriptions or in their advertising. So, we're trying to hopefully, by educating people, give them a better understanding of how we differentiate from these other products, and how we're much more effective at being able to extinguish fires and deal with these emergencies. So with that, I want to thank everybody. You have a rest of, hope the rest of your day it goes well and safe travels if you still need to go home. And thank you for joining us, and we look forward to seeing you at our next. With that, have a great evening, great day, morning, wherever you may be. Thank you.